We are looking at determining end behavior of a function, and we're going to look at finding zeros some more. I know we already looked at finding zeros, but we're going to look a little bit more into it. Finding zeros is something, but the process of finding zeros is something we need to be able to do extremely well, so it's good that we're hitting it again. So those are the two things we're looking at. It's pretty straightforward, so hopefully we don't have any issues with it. But we are on page 104. The first example we want to look at is f of x equals 2x to the 6th plus 4x to the 5th plus 9x squared. So what do I mean by end behavior of a function? What is it I'm talking about? Gotta have some thoughts. Where are you got the shirt? You sure? There's one that's also good.
Well, it's for go on team or cousin.
Alright, end behavior of a function.
What it does when it's graphed?
Okay, more specific. You're on the right track.
What is it?
Something to do with the graph.
It's like when the
You're getting closer. You're getting closer. Now we're on the right track. Okay, AJ just said how it ends. What do you mean by how it ends? Alright. Okay, so we're wanting to know out to the left or out to the right, left and right. Okay, we want to know what is our graph doing out there. Okay, and today we're talking about if it's going up, if it's going down, if it's going opposite directions, if it's going the same direction, all of that. We can determine all of that by just looking at the function. Like right now, I can tell you that this graph, both ends will end up going up. Okay. Okay. So what'd you say? What'd you say, Natasha? Okay, the biggest exponent is a 6, which is even. And did we, I think we mentioned this earlier.
I don't know.
Okay, good. So since the biggest exponent is even, what does that mean? Okay. If it's even, that means both my ends are doing the same thing. If my largest exponent is even, that means both my ends are doing the same thing. They're either both going up or they're both going down, if I'm dealing with an even exponent. Okay. So, even, it's not even. Okay, so if it's even, that means my ends are going the same direction. They're either both going up or they're both going down. If it is odd, that means their ends are going opposite directions. Okay, so that's the first thing. So back on the even, this is an even. So how do I tell if they're both going up or if they're both going down? The coefficient in front of the largest exponent tells me that. If I have a positive coefficient, that means we're going up. If I have a negative coefficient, that means we're going down. So in this case, since it's even, that means we're going the same direction. Since it's a positive 2 in front of that, that means we're going up. So when I graph this here in a second, both of my ends should be going up. Okay, what about though if it's an odd? What do you think happens if I'm positive on an odd? Say it again. Okay, here you go. No, if it's odd, that means my ends are going opposite directions.
The left one's gonna be down and the right one's gonna be up.
If it is
Odd or positive.
positive, so right side goes up. And if it's negative, left side goes up. Okay, so that's all the information you need to be able to tell what a graph is going to do, or what the ends of a graph are going to do. Okay, what do you know about a function if its highest exponent is even? What else do you know about it? With that information, what do you know about a function if its highest exponent is even?
It's gonna have an absolute.
Not necessarily a min, but you know it's going to have an absolute extreme. Okay, it's either going to have an absolute min or it's going to have an absolute max. Okay, so if it's even and it's positive, and that means my ends are going up, what is it going to have? Which one? It's going to have an absolute min. And if it's even, if it's negative and it's going down, it's going to have an absolute maximum. Okay, very good. What about an odd? What about if it's odd? One's going up, one's going down. What does that tell me about absolute extreme?
Not gonna have any.
It's not going to have any absolute extreme. Okay? All right, any questions on this? What we have written down? Okay, let's look at the graph of this first one. We said my ends should be going to the same direction and they both should be going up. So here's the graph of the first one. Notice it's going up. And since they're both going up, I do have an absolute min like we thought. Okay? Next one. Okay, f of x equals negative 7x cubed plus 8x to the fourth minus 6x to the sixth. F of x equals negative 7x cubed plus 8x to the fourth minus 6x to the sixth. Cameron, what do you think?
It's going up 8.
Say it again.
The coefficient says it's going up 8.
Going up 8. Well, first of all, tell me, are the ends going the same direction or are they going the opposite direction? Answer that question for me first.
Opposite.
Opposite directions. Why do you say they're going opposite directions?
There's a 3.
Because there's a 3. Does anybody want to disagree with Cameron? Sky?
Same, because the highest exponent is 6.
Right. You need to find the highest exponents, and the highest exponent is 6 right there. Okay? So since it's 6, that means they're both going up or they're both going down. Which way are they going, Blake?
They're both, they're both going to go down.
They should go down, which means, Kurt, I have what type of absolute extreme?
Yeah, you mean maximum.
I should have a maximum. So let's look at the graph of this one. So there's the graph of this one. Notice there's my absolute max. Notice that both ends are going down like we said they were. Alright, h of x equals 4x squared plus 5x cubed minus 2x to the fifth. H of x equals 4x squared plus 5x cubed minus 2x to the fifth. So Lindsay, what do you think about the end behavior on this one? They're going opposite directions. And which side's going up? Right or left?
Left.
Left side is going up. That is correct. So we're going opposite directions because of this. And then because that's negative, that means the left side is going up. So let's look at the graph of that one. There's the graph. Okay, notice we're going opposite directions. Left side's going up, right side's going down, just like Lindsay said it would. Very good. Okay, on this one I have g of x equals x squared times x to the 4, or times x plus 4 times negative 2x plus 1. Good question. Matthew, what do you think?
I think you would, just solve it out as much as you can.
Okay, do I need to multiply all of it out?
I would.
You would? Kathleen, what do you think?
I think you probably just need to find what the x's are, because that's what you're graphing it out of.
Okay, that's what I would do. I would just take all of my x's and multiply all my x's, because what is that going to give me? That's going to give me the highest exponent. So that's the only thing I really care about. So if I multiply these three together, I should get negative 2x to the fourth. And Lauren, what does that tell me?
It's gonna be even, well, it's going in the same direction.
In which direction is that?
It's gonna be going down.
Should be going the same direction, going down. So let's look at the graph of it. There's the graph of it. Notice both of them are going in the same direction and they're going down. Okay, Gage, since they're both going down, what does that mean? Also exists in this function.
Negative.
Reagan, help me out.
Maximum,
What type of maximum?
absolute.
Absolute maximum. Anytime my ends are going in the same direction, I'm going to have an absolute extrema. In this case, since they're both going down, I've got an absolute maximum. Good. Okay, so that is determining end behavior of a function. Okay, so now we want to look at finding zeros of a function, which you guys should be used to since we just did it recently. But like I said, we need to be very good at it, so it is popping up again. So I have f of x equals x cubed, or x to the fifth, plus 3x to the fourth, plus 2x cubed. And I'm interested in finding the zeros. Before I find the zeros, Kendrick, let's talk about the end behavior. What's the end behavior of this one going to do?
It's gonna be going opposite.
Okay, which side's going up?
Right side.
Right side's going up. Very good. Why is the right side going up?
Oh, no, I got that.
Kurt?
So there's a positive 1 in front of x to the fifth.
Because the 5 tells me we're going opposite directions, and since it's positive in front of that, that tells me the right side's going up. If it's negative, that tells me the left side's going up. Alright, so now we're interested in finding the zeros. So Natasha, what do I need to do to find zeros?
Plug 0 in for 1.
Plug 0 in for y, so we want to set it equal to 0. Okay, so we're finding zeros, we set it equal to 0. Bobby, what do we want to do next? What do you mean by solve?
I don't know. You plug 0 in, solve it.
Okay, what do you think, Colleen? You're not sure. Bobby? Factor, excellent. And what do you want to do to get started on factoring this? Number one rule in factoring is take something out if possible. What can I take out of this?
X cubed.
X cubed, so let's take the x cubed out. So that leaves me with x squared plus 3x plus 2. Okay, so we're probably going to factor it. We always want to start by factoring something out if possible. So we factor that out. Okay, how can I describe that thing right there? It's a trinomial. What do we always do with trinomials?
Get into 2 by
Factor it to 2 binomials. Excellent. So I've got x and x. Remember, I want you to be able to read that twice. What's the first way we need to read that?
Something that multiplies to get 2 adds to make 3.
Alright, that's very close to what I want. I want factors of 2 added together to get 3. Okay? Factors of 2 added together to get 3. Very good, Kevin. So factors of 2 added to get 3 are 2 and 1. Okay? How do I want to read it the second time through? Say it again. Yeah, before that, you're forgetting to read the first sign. What does the first sign tell me? What does this tell me? Same sign, and then this one tells me they're both positive. I need you guys to get to where you're reading a trinomial just the way we discussed. So factors, either added or subtracted to get a number, and then signs are going to be the same or different, and then the second one tells me signs are both the same, what the signs are, or which one's the biggest. I need you guys to do that. Okay, once we get here, we should be able to see the zeros. What are my zeros now?
2 or -1.
-2, -1, and 0. Now, on the 0, we want to say it is a multiplicity of 3, and then we have -2 and -1. Why do you think we want to say it's a multiplicity of 3? Because of that cube. That cube tells me it's a multiplicity of 3. The other ones don't have a multiplicity because what? There's no exponent on these parentheses. If there was an exponent on the parentheses, then we would have to say they were a multiplicity of what as well. So before we graph this thing, what do we know about it? Because we know some pretty good information about it before we graph it. What do we know about it? Goes opposite directions, which side goes up? Right side goes up, what else do I know? Okay, it's going to touch the x-axis at 0, -2, and -1. So let's see if that's what we got. So it goes up on the right, it touches at 0, -1, and -2, just like we said it would. So that's some valuable information that helps us get an idea what the graph looks like. Okay, let's try another one. Okay, f of x equals x to the 4 plus 4x squared minus 21. So let's talk about the end behavior first. Carson, what do you have the end behavior doing on this? Okay, which way? Up or down? Up, very good. Why are they both going the same direction and why are they both going up? Excellent. Very good. So, even exponent tells me they're going in the same direction. Positive in front of it tells me they're going up. Excellent. Okay? So now I'm ready to find the zeros. Kendrick, what do I do to find the zeros?
Set it equal to 0 and then factor it out.
Okay? And what am I dealing with here?
Trinomial.
Trinomial. What do we do with trinomials?
Set them to 2 binomials.
2 binomials. Very good. So, factors of x to the 4th are what? X squared and x squared. Now, let's see if we can read this correctly. Who can read this the two ways I want to read it? Cameron?
They're gonna be different, like one's gonna be positive, one's gonna be negative.
Alright, but I want you to read it the way I'm trying to train you to read it. Okay. Bailey?
Factors of 21 that are added or subtracted to get 4.
Okay, in this case, which one? You know whether or not it's going to be added or subtracted. Which one is it in this case? Subtracted. So factors of 21 subtracted to get 4. So what are factors of 21 subtracted to get 4? 7 and 3. So that's the first thing I want. First thing you're doing is getting the numbers. I don't care about the sign. If you try to get everything at the same time, it's going to screw you up. So the first thing we want is the numbers. Then we go back and read again. And Cameron, what do we read the second time?
7 is positive.
You're reading too much, too fast. Got it.
That tells you that it'll be different signs.
Different signs. This negative tells me different signs.
That says what the biggest.
That tells me the biggest one is positive. I want you guys to be able to do that. First thing you do is read it. Factors of 21 subtracted to get 4. You get those factors. Then you go back in to get the signs. Signs are either going to be the same or opposite, and then the other one tells you what they are. Okay, I want it done that way. So set it equal. So this one right here, I get x squared equals -7. What's wrong with that? And x squared is always going to be, this thing right here is always going to be positive, and a positive is not going to be able to equal a negative number. So that means I'm not going to get a 0 out of that. I can actually get a 0 out of it, but what type of 0 would it be? Imaginary. Excellent. It would be an imaginary 0. On the other one, I get x squared equals 3, so that means x is going to be what?
Square root of 3.
Plus or minus the square root.
Very good. Plus or minus the square root of 3. So before we go to the graph, what do we know about this graph? both ends are going up, and it touches the x-axis at plus or minus radical 3. What is radical 3? What two numbers is radical 3 between? 1 and 2. It should be between 1 and 2. So when we graph this, we'll be able to tell real quick whether or not we got it. Alright, so we said both ends are going up as it is, and then we said between 1 and 2 are where my zeros are at, so we did that one correctly. Bless you. Alright, sorry about that delay. Let's move to the next one. Okay, I have g of x equals 9x to the 6 minus 36x to the 4.
So do you think it's zero the factor?
Okay, let's talk about the end behavior first. What do you know about the end behavior?
It will, it's positive, so they'll go in some direction.
Okay, so even tells me the same direction, positive 9 tells me they're both going up. So since they're both going up, what does that tell me about my function?
It has a minimum.
It has an absolute minimum. Very good. Okay, so as Sakaya said, set it equal to 0. Gives me that. Matthew, what do we recommend we do next?
Factor it.
Okay, how do you want to do that?
9x4.
Say it again.
9x to the 4th.
Take a 9x to the 4th out.
Yeah.
That leaves me with x squared minus 4. Very good. Okay, Blake, what do you recommend next? AJ, what do you see? Okay.
I'm gonna nail it, but you can still factor it out. So it'll be like x minus 2x plus 2.
Excellent. Who can give me a name of that?
Binomial.
Perfect square.
Nope.
Yeah, exactly.
We need to know the name of that. It is a difference of two squares.
Oh, there's something
You got two squares and you're subtracting them. Difference of two squares. Okay. So now I've got it factored. I should be able to see my zeros by now. What are my zeros? And what can I say about 0? Multiplicity of 4. And then I have 2 and I have -2. So we said both ends should be going up and it should be touching the x-axis at 0, 2, and -2. Yes.
What the heck is multiplicity for?
That means that that 0 occurs 4 times.
Okay.
Is what it means. Good question. So we know both ends are going up and it touches the x-axis at those 3 spots. So let's check that. Here it is. Both ends are going up. We touch at -2, 0, and 2. Notice what's happening at 0. What is happening at 0? Does it cross or does it just touch? It just touches. Okay? What about it might possibly tell me, what about what I have written down here might possibly tell me that it's just going to touch and not cross?
There's no middle.
Alright, that's a good thought. That's not it, but that you're noticing something, yes. Kathleen?
The y-intercept is 0.
Okay, y-intercept is 0. That you are correct on that. That's not what's going to give it away. Does anybody see anything else?
Multiplicity.
What about the multiplicity?
It's a 4, so. And
If your multiplicity is even, you're only going to touch and not cross. Okay, if we go back to, we had another one where the 0 had a multiplicity of something else. It was 3. And what function was that?
X to the fifth plus
3x to the fourth plus
Okay, so on this one we had a multiplicity of 3, and notice what's it doing at 0? It's crossing. Okay, so if your multiplicity is an even multiplicity, you're going to touch. If your multiplicity is an odd multiplicity, you're going to cross. Okay. That's free. It's free knowledge right there. It's bonus information. Alright.
I did bonus on
I want to do the same thing on this. I want to talk about the end behavior, and I want to find the zeros.
Okay.
So what do you think on this one?
Which multiply the x's together.
Multiply the x's together. Very good. So what do I end up with if I multiply the x's together, Mike? Blake, what do you end up with?
X to the fifth,
How do you get x to the fifth?
multiplying, or there's a word I'm looking for. Distributing, that's the word. Distributing x to the other x.
Okay, I agree with that, but I don't see how you end up with 5. How many should we end up with?
4.
We should end up with 4. Because this one ends up being x squared. So x squared times x is cubed, and times another x, I end up with x to the 4th. So what does that tell me about my function?
It's
Both going out.
They're both going up. Excellent. They're both going up. Okay, now what do I want to do to find the zeros? Set it equal to 0. And what do we usually do after we do that? We factor, but what's going on with this one? It's already factored. Yes, ma'am. Okay. So this one's already factored, so what are my zeros? 0, -4, and 1. What do I know about 1? Okay, and since it's multiplicity of 2, what does that tell me about the graph?
It just touches.
It should just touch, it should not cross. Okay, so I know both ends are going up, I touch at those 3 places, and I should not cross at 2. So let's look at the graph of that. And let's see. There it is. So there's my graph. Were we right? Both ends are going up, and at 1 I only touch, I don't cross. Okay? Alright, so now we're going to do kind of the opposite direction. They're going to give you a graph, and from the graph, what do you think I'm going to have to find?
0.
I don't need to, I'm not going to find the zeros. We've done that before. Alright, I'm not going to have to create an equation, but I can figure out something about my equation. What can I figure out about my equation?
You can figure out
What is it?
I can figure out that my largest exponent is even or odd, and I can figure out the coefficient of the largest exponent is positive or negative. That's what we're going to do here. So on 65, the first thing I want you to figure out is your biggest exponent even or odd? So my biggest exponent is odd, and then is my biggest the coefficient of the biggest exponent positive or negative?
positive.
It is positive. How do I know it's positive? The right side's going up. Very good. Okay? Kurt, what about 67? Is it even or odd?
It's even.
Biggest exponent is even, and is the coefficient positive or negative? Coefficient is negative because both ends are going down. Excellent. Okay? So, we learned how to determine end behavior of a function, and we were finding its zeros. And we were using all that to get a pretty good idea of what the graph was going to look like. Any questions on that?
Okay, I'm
You're good?
looking. Yeah, check that.
Alright, here's your assignment. It's not.
Yes,